Hold that.
Okay, you guys have just a couple minutes. Make sure you clean that up before you go.
Yes, sir. Good. So I'm at 1,000. Pop it up, pop it up, pop it up, pop it up. Pop it up. Pop it up, yes. What did you do? Pop it up. What the? That's our homework. Returning your scissors. Thank you for letting me use them. You're welcome.
Have a nice weekend.
See you Monday. See you Monday. It's my brother's religious drive day. I can find mine.
Mr. Tubman, can you sign my GPA verification?
No math teacher this year?
I'm taking like medical math, but it doesn't actually count as a math, so
Medical math.
yeah, it's really easy. It's like basic like reading medical graphs and stuff.
How did you like BC?
What? Sorry.
You took BC, didn't you?
Oh yeah, I liked it. I liked it a lot. I don't think I liked it as much as AB, because like in AB I gotta like learn all this stuff for the first time. And BC was just kind of growing off of that, but it was good.
They made me teach BC this year since Miss
Yeah.
Cross left, so
Yeah, I heard. I have a couple friends.
Trying to figure it out as
Yeah.
we go.
Yeah.
I know I can do it all, but I've never had to teach it. It's
Mhm.
just a different level.
Yeah. I think, at least I feel like for me, it's like easier to build off of like AB going into BC, so it's not like a huge.
Yeah, I'm trying to just show them a BC thing every once in a while,
Mm-hmm.
and then mix in AB review that they
Yeah.
are mostly comfortable with, so that it's never too hard. But
Yeah.
But my first grade class is not worried at all, so I need to make it a little harder.
Just walked into the wrong classroom. How? I was on my phone and I was just walking in and I was like, it's Dr. Grisham's room. I did it the first day. I like walked in and sat down. And I was like, I know these people aren't in my class. And then I walked back out. God, those numbers. Oh my god.
Make sure you get this turned in today.
Yeah, I will. Thank you so much.
Yep.
I think I left my jacket in here yesterday. Have you seen it?
There's a black jacket back on the counter. I don't know if it's yours, but probably.
I think it is.
I do need your number 17 homework, and you need to get out a blank piece of paper. as always, it's easier before everybody else gets here. But up to you, I guess.
I hate when people don't get that. Don't match the So you're not doing that. You're actually like made I was 28. I know. I love those different.
Sometimes there's still no heat in here. No heat.
It was so fun.
Okay, I have no idea why the bell didn't go off, but it should have gone off. All right, if you did not give me number 17 in Google Classroom, this is your last chance to get full points on it.
I would. And I was trying to get tickets. Where'd you go? Monica. But worth it to me. My mom took me out too, so it wasn't even like.
For the record, I never said you were dumb.
Okay, that's not what I heard.
No, I said you were smarter than me, but you lose it with common
Okay.
sense in driving. Yeah. See that? That makes more sense. Okay, but you backed into a car and said, "Oh, last year."
Oh, really? Yes, I know. That humbled me. Last year, I was in the parking lot and I was in a rush and I backed into the car. But like, I'm 16. Yeah, she's a minor. It's not my fault.
All right, welcome back, guys. I got to share a little bit more information with you guys so that we can practice some more derivative stuff. But the stuff that we talked about yesterday, you're going to see comes up with this as well. So if you didn't feel like you had mastered yesterday's stuff, it's going to just keep coming back up, so it should get easier with time, but we need to add to that. So first off, I need to share with you, I think I might have mentioned this yesterday, I don't remember, but so derivatives, of course, are not just some random math thing that we just practice to see if we can do it. Derivatives certainly have a lot of real-world implications, and so the first that I need to expose you to, so that we're not just always talking about generic functions, just doing generic derivatives, is this relationship between position, velocity, and acceleration. Now, I think it was y'all that I mentioned on that graph yesterday, the relationship between position and velocity, or was that my other class? It was here? Okay. So if you didn't catch that, this is the relationship you need to know between all of these. So a position equation is usually S of t or x of t. Those are the way it's usually written. And that tells you where something is at a certain time. If you want to know where it is at 5 seconds, you plug 5 in for t. You want to know where it is at 10 minutes, you plug in 10 for t. But if you take the derivative of position, that actually represents the velocity equation. Now, velocity basically means speed, but not quite. So sometimes for velocity, we'll say v of t, and sometimes we might say the derivative of the position, because it's the same thing. If you take the derivative of position a second time, second derivative, that is how you get acceleration. So acceleration we would usually call a of t. What's another way to find acceleration besides the second derivative of position?
Change in velocity over time.
Or just say the derivative of velocity. So taking the derivative of position gives you velocity, taking the derivative of velocity gives you acceleration. Now, this is a topic that we will do even second semester when we do integration. Remember, integration is just going to be the opposite of derivatives. So second semester, I might give you an acceleration equation, and you can integrate it back to velocity and then integrate it a second time back to position. So this relationship between these three things is what we need to know. Also, very small difference, and I probably didn't correct anybody if they said speed yesterday, but there is a difference between speed and velocity. Velocity, when velocity is positive, that means that something is moving to the right or up, depends on the context of the question. If velocity is negative, it means it's going left or down, depending on the context of the question. But speed is always positive. Speed does not measure direction. Velocity does measure direction. Okay, so a couple quick examples to finish up this side, but here's a position equation and just kind of talking about what would the position, velocity, acceleration, and speed be at these times. So this says S is in feet. Let's go ahead and add that T is in seconds so we can practice with units. It is important that we get down the correct unit stuff because they do give points to that sometimes on your AP exam. But if you want to know the position at 1 second, you're just going to plug 1 second into the position equation, do the arithmetic, and then you know he is at 7 feet at 1 second. Of course, if you wanted to know where he was at 100 seconds, you just plug in 100 instead. If you want to know the velocity at 1 second, you have to, the calculus you have to know is to go from position to velocity. You've got to take the derivative, and to be able to do the derivative of this type of function, you have to know power rule, and know the derivative of the constant is 0. So we talked about those last time. I'm not going to focus too much on the derivatives here. But then once you know the velocity function, you can figure out the velocity at any given time. If you want to know the velocity at 1, you plug in 1. Now, realize velocity is very similar to speed. So velocity is going to be a distance, in this problem feet, per amount of time. Okay, speed is the same as velocity except that it's always positive. So the speed here is going to be the absolute value of the velocity at 1. So that would be positive 2 feet per second. It's like asking you about driving a car, how fast did you go? You would never say negative 55 miles per hour. Nobody's interested in the direction you're going. So you would just say 55. Speed doesn't come up as often, but it does come up. And then finally, acceleration. The calculus you would need to know is that taking the derivative of velocity gives you acceleration. And just based on this one, well, you'd have to do power rule, and you have to know the derivative of the constant is 0. But it looks like acceleration is always 2. There's no t here, so it never changes. So whether it's time 1 or time 3, the acceleration is going to be 2. Now, acceleration has different units than velocity. If velocity is feet per second, acceleration will be feet per second squared. Position is always a location, feet, inches, miles, etc. Velocity will always be a distance per time, feet per second, miles per hour, and acceleration will always be a distance per time squared. Feet per second squared, miles per hour squared, something, oops, Okay, and then the only other difference over here is if you wanted to know at 3, instead of plugging in a 1, you'd plug in a 3. But if you have the position equation, you just have arithmetic left over. So it looks like this particle, as it moves back and forth, left and right, at second 1 it's at 7 feet, and also at second 3 it's at 7 feet. It's gone back to that location. If you want to know the velocity at times 3, you need to plug in 3 into the velocity. So 6 minus 4 would be 2, and that would be feet per second. If the velocity is 2 feet per second, what would the speed be? Okay, why not negative? I thought it's supposed to be the opposite. This went from negative to positive. Why didn't I go positive to negative? Right, it's always positive. Now, in this course, did I talk about the third derivative? Did I make that terrible joke with y'all? Okay, so in this course, we do practice sometimes doing a third or fourth derivative. You can take the derivative of something as many times as you want to. But as far as our applications go, 2 derivatives is the max. If you start at position, take the derivative once to get velocity, and then take the derivative a second time as acceleration. Someday in a science course, you might take a third derivative for an application. Does anyone know what a third derivative is called? Okay, someday you may, I'm only pointing this out to you, because someday you may see like a t-shirt or something that will say, don't be a third derivative. People wear that sometimes. Third derivative is called a jerk. It measures jerk. So if you ever see that, you'll at least understand the math joke. Okay, so not a big deal. Again, I just plugged in numbers for all of this stuff, talked about the units, but this is the calculus. Knowing what happens when you take its derivative, what happens when you take its derivative, power rule, derivative of constants are 0. Not hard derivatives to take, but you got to understand that relationship. Okay, on the back of this, I've got a couple question types that tend to be some of the stuff that confuses students the most. So I went ahead and added them to these notes so that you'll see it now and you'll see it again later on. So you'll be exposed to it more than once. Okay, did I talk about, well, actually I don't want to give this away, but this is a question we used to put on a test. It used to be on the calculator portion of a test. They give you the velocity function and they ask for acceleration at 1.5. So how are you supposed to take velocity and change it to acceleration? Okay, so the acceleration at 1.5 is the same thing as the derivative of the velocity at 1.5. Now, if I had given you like a homework quiz or something today, I think even this question would have been fair game, because how do you take the derivative of that? This T messes it up. You can't do that. Good. You should be struggling because you don't know how to take the derivative of something that looks like this yet. Not until the end of this unit will you be able to take this derivative by hand. But that doesn't matter, because remember you have a calculator, and I said it was on the calculator portion of a test. We did talk about using calculator yesterday. Okay, so alpha window, option 3, and then again, sometimes your AP exam, so I do the same thing for y'all's test, sometimes on the calculator portion they're going to give you something that you literally cannot take the derivative of. Any time you spend on it is a waste of time and it's going to be wrong. But assuming you are in radian mode, you can just ask it to take the derivative of t squared, or was it t squared? Is that what it is? T sine of t squared? Okay. And you can do t's if you want to, but I just put x's there. As long as you're not interested in the derivative, but you're interested in the derivative at just one instant, like 1.5. Now, I think this is the first time I've said this year, but everything in calculus is in radians. As you guys go higher and higher into math courses, everything in higher mathematics is radians. We don't do I can't think of anything we do in degrees at all. So it's not like pre-calculus where you need to jump back and forth. Basically, if you know the derivative of velocity gives you acceleration, and you want the acceleration at 1.5, just ask your calculator. And that came out to be negative 2.048. Okay. We always need to round to 3 decimal places. Your AP exam, free responses expect 3 decimal places. That's why we ask you to do that in pre-cal. What about, since this is acceleration, my units would be something like, I'm just going to make up units, but it's going to be something like a distance per time squared. Acceleration is a distance per time squared. Now, this isn't that important right now, but the fact that acceleration is negative means that the rate of change of the velocity is increasing to the left. So he's moving to the left. Well, actually, I don't know that he's moving to the left, but his speed is increasing in the left direction. But we'll talk about that more later on in the year. Okay, another thing is these velocity graphs. So this is pretty common FRQ for your AP exam, that they're going to ask you something like this. And obviously you're probably not that familiar with using velocity graphs, but let's put some units in here. Time we can say is in minutes. Velocity can be whatever. Let's say feet per minute. So they are not showing you the position. This doesn't mean at time 0 he's at 0, and at time 10 he's at 60. It means at time 10 he's doing 60 feet per minute. That's his velocity. So the first question is, when is he moving to the right? Okay, well, when's it positive? Not 0 to 10. Why is 0 to 30 positive? Right. Things above the x-axis are positive values. So your justification would be, well, when the velocity is positive, it's moving to the right, and it's positive above the x-axis from 0 to 30. Now, I heard a bunch of people say 0 to 10, and I know why you're saying that, but you're looking at slope there. I want to know when's the velocity positive, and this is the graph of velocity. It's positive when it's above the x-axis. Therefore, it must be moving left when the velocity is negative. When is the graph negative?
30.
Good. 30 to 55. Not 60. Be careful with that. Is there any times that this particle, we talk about particles moving back and forth just as just something very generic, but is there any time this particle is at rest?
No. Yes. Yeah, it's going to continue, right? No, 0 and 30. At rest it would be.
Okay, let's not even look at this question. What would be happening with the velocity to be at rest?
0.
Okay. Is there any times that this graph is at 0?
0 and 30.
At 0 seconds
And 55 or 60.
and 30 seconds and not 60 but 55. Again, you're going to see this again later, but I just think that showing it to you earlier makes it easier the second time you see it. But what you should appreciate about this is when you see these as FRQs, this is some of the easiest justification you can do. Here's when it's moving to the right, and here's how I know this. It's not some 3-part definition like proving something's continuous. Simply knowing when the derivative is positive is when you know it's moving to the right. When the velocity is negative, you know it's moving to the left. When the velocity is 0, you know it's not moving. So very easy justifications, and honestly, these answers are not that hard to extract out of the graph. Be careful though that you're not oversimplifying this. don't say, okay, I'll just memorize this when it's above the x-axis, I'll memorize this when it's below the x-axis, and I'll memorize this when it's on the x-axis. That's not a good long-term strategy because we don't always look at velocity graphs. Sometimes we might look at position graphs. Sometimes we might look at acceleration graphs. So you need to, the highlighted parts are the most important piece there. Okay, and stuff that you are getting sick of me saying are going to help us with this last part. You can start to see why I've been trying to emphasize it so much. I can see velocity values, but the last question wants me to say what the acceleration is during each of these intervals. How am I supposed to know something about acceleration from velocity? Okay, you can take the derivative of velocity to get acceleration, right? Sometimes that means you've got a function and you take the derivative. But the other thing is, what else does derivative mean? Slope. So sometimes when you want derivative, you've got to think of slope. And sometimes when you want slope, you need to think of derivative. So right here, the slope slash derivative of velocity is how you know what the acceleration is during that time. So you can just count rise over run, and you know what the acceleration is during that time. Here, rise over run, the acceleration from 10 to 15 is 0 feet per second. He's going the same speed. Of course he's not accelerating. During all of this time, the slope's the same. So during all of that time, the acceleration is going to be the same. Count your rise over your run. That's -4 feet per minute squared. And all of this has the same slope, so you can count rise over run there, up 40 to go right 15, which reduces to 8/3 feet per minute squared. So, a couple things about this that I just want to highlight again. I've been trying to bug you to death about knowing that derivative and slope are the same thing. You can quickly realize you need the derivative of velocity to know something about acceleration, but it also means that you have to know that you're looking for slope there. Obviously, counting rise over run for slope isn't that difficult, but sometimes we care about the slope, sometimes we just care about the values, sometimes we care about the x-intercepts, but that's where all of that kind of pieces together. Okay, anything that you'd like to clear up about this before we move to the second part? Okay, you won't actually need to use any of that today. Again, I just like to show it to you as early as possible because I think it makes it easier when you actually have to know it. Okay, so to build upon us doing derivative work from yesterday we memorized a few that we have to memorize, and we did the power rule a bunch of times. We're going to do the power rule a bunch more times today. But if you look back at your notes, when we did derivatives yesterday, we talked about if you want to take the derivative of something plus something, you can do them separately and then slap a plus sign between them. You want to take the derivative of something minus something, take the derivative separately, and then slap a minus sign in between them. I did not say anything about multiply or divide. Even though multiply and divide does work that way for limits, it does not work that way for derivatives. So when we are taking the derivative of something times something, we call it the product rule. Remember, here in product means multiply. And then when we want something, what does quotient mean, Johnny?
The product of division.
The product of division. Try again.
Quotient, like the answer of a division problem.
Okay, division, thank you. So if we have something divided by something, we have to do what's called the quotient rule. So both of these are kind of formulas or patterns that we have to memorize, but the first thing you really have to check off in your head is if you want to know the derivative of this, you may not, and every year a few people do this, and it makes you really confused for a couple weeks. You cannot just take the derivative of this, put down a multiplication symbol, and then take the derivative of that. If it was that simple, I would have just put it on your first day of notes, because that would have been intuitive. We have to follow this formula that's called the product rule. And it looks pretty complicated, but all it really says is think of these as something times something. And the way you're going to work them is you're going to take the derivative of the first thing times the second thing left alone. Notice this one's derivative, this one's not derivative. Plus, then you're going to take the derivative of the second times the first left alone. If we follow this pattern, it's going to do the derivative correctly for us. So, to find this derivative, I'm going to try to color coordinate this for you. But I know power rule is still pretty new to you, so if you need to go over to the side and do the power rule for the square root of x, you could bring the power down, lower the power by 1, but it becomes this. You're going to get plenty of power rule practice later today, so I'm going to go through some of those pretty quickly. Times the second part left alone, and then plus the derivative of the second part, but the derivative of e to the x is e to the x, times the first part left alone. Sometimes you're done, and even if you're not finished, the calculus should be finished. That is technically the derivative. Derivative of the first with the second left alone, plus, and then do it the other order. Do the derivative of the second with the first left alone. Technically, you could do these two in either order because the order of addition doesn't matter. Addition is commutative. 5 plus 3 is the same thing as 3 plus 5. So whether you do this plus this or that plus that, you get the same answer. Now, when we get to the book assignment, you're going to see kind of the headache in this unit is the simplifying. So technically, this is the derivative, but we will try to simplify our answers until they match up with the back of the book. I did print out the odd answers on the back like I did for you guys yesterday. So it just depends on what type and how much of a pain the simplifying is going to be. And a question like this, I would say you probably need to at least factor out the e to the x. So the frustrating part of it is I can't tell you a hard and fast rule. If this was a free response and it said find the derivative, you could stop right here where I box this in because technically it's the derivative. But more than likely, as a multiple choice question, there's going to be some simplifying, like maybe factoring out an e to the x. Just depends. Okay, so let's do product rule one more time here. So here's the function. Here's where I'm saying it's the derivative. I've got something times something. And I want to practice the product rule. So, what does the product rule tell me to do first?
The derivative of x cubed.
Okay, and if you know power rule, that's 3x squared. What comes next? Somebody else.
Then you just bring down.
Okay, leave the second part alone. Good. And then plus, what comes next? Okay. And that would be, derivative of this would be this. You can just trust me if you don't know why that is. And the derivative of the constant is 0. Okay, and then last part is
X to the third.
right, the first part left alone. So technically this is the derivative. Again, as a multiple choice question, there's probably going to be some simplifying done to it, but technically that is the derivative. That pattern is what will always work for these. Now, this is not that important right this second, but just a heads up. Honestly, if I was doing this question, I probably wouldn't do product rule. I think I have probably mentioned a few times, if you can do any algebra first before the calculus, that usually makes it easier. What I would normally do is just distribute. And the reason why I would distribute first is because then I only have to do the product rule twice, and that's also the derivative. So you have options at least. Okay, the other one we need to practice today is quotient rule. And Johnny was able to tell us after about 30 seconds that quotient means divide. And so he's got a pattern or formula as well. It also looks pretty intimidating, but again, after you practice it a few times, you start to get the hang of it. It's really just a pattern. So if we call the numerator f of x and the denominator g of x, it says take the derivative of the numerator. We'll just do question 3 as we go through it. The derivative of e to the x is e to the x, stays the same, times the denominator left alone, which would be sine x in this question. Subtract, now I'm going to take the derivative of the denominator, which would be what? Good, cosine x, times the numerator left alone, so times an e to the x, and then you put it all over the denominator squared. So sine squared looks like that. So other than memorizing the formula, I'm still taking the derivative of sine that we memorized. I'm still taking the derivative of e to the x, which I memorized. I'm still using the power rule, which we do a million times. So it's not harder. It just takes practice to get comfortable with the formula and piecing it together. Okay, that's the only one of those I have until we get to the bottom of this page. So is there anything that jumps out at you about the quotient rule you'd want to ask? The other thing to keep in mind, I feel like this is a lot of information, but keep in mind that College Board only expects you to do a handful of derivatives by hand. They expect you to memorize some, and you guys have already seen more than half of those. They expect you to do the power rule, which you should feel pretty good about. They expect you to do product rule and quotient rule, which you'll feel better about by the end of class today, because we're about to practice it with the rest of our time. And there's only other, well, using a calculator, but you've already seen that. The only other one is chain rule. So of all the type of derivatives you need to do by hand, by the end of class today, you're going to have at least seen them all except for one. So it is a lot of information, but it does get significantly easier. Okay, I also want to squeeze in here, share with you the derivative of the 6 trig functions. I told you 2 of these yesterday. Derivative of sine is cosine, the derivative of cosine is negative sine. We use those all the time. Sometimes we do these other 4, and you will need to memorize these other 4 eventually. You don't need to memorize them before class on Tuesday, though. The one tip I would give you that makes it a little bit easier to memorize them, though, is anytime you're taking the derivative of something that starts with c, what do you notice about all of those derivatives? They're all negative, and anytime you take the derivative of something that doesn't start with c, you see how they're all positive? So that helps you keep that straight a little bit. I can also show you, I'm not going to do it to you today, but I could show you why the derivative of tangent is secant squared. And I don't want to take the time to do that real quick, but how do we normally break tangent up as something divided by something? If you wanted to change it to sine over cosine and then take the derivative of this, how would you take the derivative of this? Right, it's the quotient rule. If you're willing to do the quotient rule to that, and then you're going to have to simplify some of it with the trig identity or 2 that you've seen before, you'll see why it equals secant squared. But we use it too much where you don't want to have to do that all the time. So eventually you'll need to memorize those. Okay, so now I want to practice these 4, and I'm going to do the first 2 with you, and then I'm going to have you try the next 2 to see if you're thinking along the right path. So if I put question 4 on our next quiz, what I would hope that you would do is you would say, okay, I'm taking the derivative, so now it's g prime. This is 3 times secant. So the constant multiple rule says that the derivative is going to be 3 times whatever the derivative of secant is. You're going to memorize the derivative of secant. It's at the top of your page, though, or bottom. Sorry, is it on the bottom?
On the back.
It's on the front. So you'll memorize the derivative of secant to be secant x tangent x, and you're halfway done. Then the rest of it, this is going to be negative 10 times the derivative of cosine, and the derivative of cosine is what? Negative sine. So basically, if you have the derivative of secant and cosine memorized, you have all the skills needed to take that guy's derivative. But again, this is the constant multiple thing. I know this is a little unfamiliar at the start of the year, but this is just 3 times bigger. This is 10 times bigger, or negative 10 times bigger. Okay, and then if I do put a question like number 5 on your test, you guys know multiple choice questions have the right answer and should have the 3 most common wrong answers. So I think most people, by the time we get to our next test, will know. I'll just deal with the 5 later. But what's going to happen is you're going to take the derivative of e to the x to get e to the x. You're going to take the derivative of sine to get cosine. You're going to take the derivative of this to get cosecant x is negative cosecant x cotangent x, and that's going to be one of the choices to pick from, and that is not correct. What did I not think about here? Right here, you have to use the product rule. You don't get to just take the derivative of these separately and then throw down a multiplication symbol. I wish that was the case. We could totally skip this lesson. But to do this, you have to do the product rule. You'll have to say, I'll do the derivative of the first with the second left alone, plus the derivative of the second with the first left alone. And then this part was right. This part you can just memorize. But you've got to realize when you have to use product rule and when you have to use quotient rule. And probably on the test, I'd probably also factor out e to the x before I wrote down the right answer. But take a second and go ahead and start question 6. I probably won't give you the full time to finish it, but I want to see if you take the correct path or not. Well, then we'll go over it, do the same thing with 7, and then we can shift over to the book assignment. Now, the book assignment is very long. I don't know if I said this at the start of class, but we won't get very far in it today. We'll use our class time to work through it, and then I'll ask you to do a couple more for homework just to get you to think about it. But you will not have to do all of that for homework. It'll be way too much. So don't worry about the length of the book assignment at this point. I will give you more class time before I take it up. Again, unless you work very quickly.
We are cycling.
Unless you work very quickly, you probably didn't finish question 6. But again, I just wanted to see if you were at least heading down the correct path. So in question 6, right here, you are more than welcome to do the quotient rule for this if you want to. But because this is just a constant, you don't have to. You had questions like this yesterday. You would have rewritten this like this so that you could do the power rule. If you'd rather do the quotient rule, you can. It's just more work than necessary. But then you've got minus this times this. Your only option for this part of the derivative is product rule. Anything else you try to do is not going to work. You should do the derivative of w squared times tangent w plus w squared left alone times the derivative of tangent w, which is what? Secant squared w. And then again, you might need to simplify it some, but technically that's the derivative. This has to be product rule. W squared times tangent w. I can't force those together. This one can be rewritten so you could do power rule though. Okay, correct that if need be, and then spend just a minute on question 7. Make sure that you see what path you need to take for number 7 before we keep going. Time's up for number 7. So again, I would love to just take the derivative of cosine, take the derivative of 3 minus 2 sine t, and then throw a divide sign between them. That's not how it works though. This is something divided by something. You have to do the quotient rule. So as we start practicing the book assignment, you're going to figure out this pattern, and I always try to phrase it the same way for you. Take the derivative of the numerator times the denominator left alone. Minus, and then do the opposite. Now I'm going to do the derivative of the denominator times the numerator left alone. And it all goes over the denominator squared. Now again, I'm probably going to have to simplify it, but technically that is the derivative. If you can do the derivative of cosine, and you can do the derivative of 3 minus 2 sine t, and you can memorize the quotient rule, then you can take this type of derivative. But the main thing I want you to see is that you try to use the new formula that I gave you, and not try to do it some other way. So, make corrections there if you need to. I would leave that out if I was you. And then on our book assignment again today. Again, I will need these back at the end of class like yesterday, so please don't write on these. But go ahead and copy down the full assignment for number 20. Again, I know we won't come close to being near the end today, but go ahead and copy the whole thing down. And then try question 3. I'm going to try to give you guys a few minutes head start. I will follow behind you and work as many of them as we have time for until we run out of class time. So. Okay, is anybody still copying down the assignment? Can I take it off the board? Okay, so as you start working through these, what I'd like you to do is obviously try it out. Lean on your notes a lot. You're going to need to look at your notes. Anytime there's a trig derivative you haven't memorized yet, you're going to have to look at your notes for the product rule formula and the quotient rule formula until you've got those down, but try to use those less and less as you go through the assignment. But also, equally important, you need to check your answers as you go along. So once you take the derivative for question 3, flip a few pages back and make sure that you get the same answer as question 3. Your derivative probably looks a lot different than that, which means they have simplified it some. So I want you to think about, how am I supposed to simplify that to get that answer? Because that's what's going to happen to you on multiple choice questions. Take the derivative and then you don't immediately see your answer. It's because you got to simplify some. Okay, so if you feel like you need help with the derivative part, go ahead and follow along with me. So this would be, well, honestly, if this was my question and I needed to do it, I would just distribute and then do the power rule twice. But the direction specifically said use the product rule. So I'm going to take the derivative of this times this left alone plus the derivative of this times this left alone. You guys okay with that? You understand why the square root of t is 1 over 2 square roots of t? You only saw that for the first time yesterday, so if y'all need to, if I'm skipping past something too quickly like that, I need you to speak up. Sure. So if you wrote square root of t as t to the 1/2, then you could do power rule. You could bring the power down, lower the power by 1, and then since that's a negative exponent, you would move it to the denominator and then change it back to square root. That's where those come out. Again, I don't expect you to do it as quickly as I did. I expect that you probably did it out to the side. I tried to give you a minute head start. Okay, so the problem is, and this is just going to vary, and this is where you guys are going to be frustrated with me because it just depends on, do you need to do more work here? If this was a free response question and it just asked for the derivative, this is the derivative. Circle your answer and be done. But most of the time, it's going to be multiple choice. Here's the correct answer sitting down there, and I'm going to hate that you can do the calculus but not realize that these two things are equivalent. So, what algebra, the calculus is done. The calculus is not going to get any harder than this. Power rule, product rule, quotient rule. That's all you got to worry about today. But the simplifying, what could I do with this mess of stuff that might make it closer to looking like this?
Distribute.
Okay, you could distribute if you wanted to. I'm not going to distribute. But I look at this and I see 2 big terms, and this is one big term. What's one way to force this stuff together? A common denominator. Very good. So this guy already has a denominator of 2 square roots of t. If I want this guy to have a denominator of 2 square roots of t, I need to multiply the numerator as well, so that it's like I'm multiplying by 1. And then, once they have a common denominator, you can put it over that common denominator, and then you start to see, oh, that kind of makes sense. That's how they got that as a denominator. When I multiply, oh, sorry, I don't need to multiply that. So, this already had the correct denominator, so that stays 1 minus t squared. But over here, I had to multiply the top and the bottom by 2 square roots of t to get it to have that denominator. So I need to figure out what all of this mess of stuff multiplies together to be. Got a negative 2 times a 2, which would be negative 4. What's the square root of t times the square root of t going to be? Okay, multiply that by another t and you get... And then now, do you see where it's coming from? Got a 1. Combine your like terms. Minus 5t squared. And that's how you figure out how to simplify it. Now, I don't think there's any other questions we're going to get to today where you have to get a common denominator. But you've got to realize sometimes that's what you've got to do to simplify. Once again, it's one of our million examples. Where power rule's not too bad with some practice, product rule's not too bad with some practice, but the algebra of seeing to get a common denominator, being able to get a common denominator correctly, that's where people struggle a little bit more. So go ahead and make corrections there if you need to. Move on to the next question, which I think is number 5. Check the answer at the back. If yours doesn't look the same as it, question your calculus. Then question if you can simplify it. But if you get it right, just keep on going. And if you get stuck, wait for me to go over it to help you get unstuck. Use your notes as much as you need to, but just try to use them less and less. Over time, try to memorize those 2 patterns. Okay, I'm going to assume you either got 5 correct at this point or got stuck on it. So again, I don't want you to follow along with me. If you've already checked your answer, know that it's right and feel good with it. I want you to just keep going. Stay productive. Okay, but number 5, you should know it's product rule because it tells you in the directions, but also because it's something times something. So in your head, before you looked at your notes, try to remember as much of this as possible. Derivative of the first with the second left alone plus the derivative of the second, which changes that from a plus to a minus, times the first left alone. Then you can go check your answers in the back, but this is not what the answer looks like, so you need to keep going. However, the nice thing is, this one's a lot easier to simplify than question 3. This one, all you can do is factor out a GCF. So it's not that the simplifying algebra is always going to be a pain, but sometimes it is. So, okay, make corrections there if you need to, and then keep going. Try to stay a few questions ahead of me, please. Okay, number 7, for those of you that got stuck or could not figure out how to make it look like theirs in the back. Once again, the directions are telling you to use quotient rule, but you should realize it's quotient rule because it's something divided by something else. Now, if just one of those is a number, we don't have to do this, but if this is a function and this is a function, we have to use the quotient rule. So, take the derivative of the top times the bottom left alone minus the derivative of the bottom times the top left alone all over the denominator squared. The hardest part about that is just memorizing the formula, which will get easier with time. You go to check your answer, none of the answer choices look anything like that. So then you realize, hey, I've got to simplify this sum. So you should realize that right here, this is like minus 2x squared. And then you can combine like terms. 1x squared minus 2x squared would be minus an x squared. And we've got a 1 over that denominator. And I think that's how they wrote their answer. That is? Okay. That's the 3rd time I've done it, so I'm starting to memorize the answers at this point. But so again, if you can take power rule to get the derivative of x, you can take the power rule to get the derivative of x squared plus 1. And if you can memorize the quotient rule, then you can do derivatives like this. Okay, next up I've got question 9. This one was significantly harder to simplify. Not that you had no shot at it, it's just that it was harder. So, again, the calculus part shouldn't be too much worse. This has to be quotient rule. I've got a function divided by a function. Quotient rule says take the derivative of the numerator. Which again, I know this is new to you, so you might do that out to the side. Also, we just take the derivative square root of x so much that, I don't know, it's nice to memorize, but you don't have to. Times the denominator left alone, minus, and then do them the opposite way. Now the derivative of the denominator times the numerator left alone. And the most commonly forgotten part of that is over the denominator squared. So technically that's the correct derivative, but multiple choice answer is never going to look like that. There's a lot of simplifying that can be done. Did anybody have a suggestion on how to simplify this? Yeah.
So you multiply the top and the bottom by 2 square root of x,
Okay, and how do you know to do that?
because there's 1 over 2 square root of x in the numerator.
Right, so remember, this is like a small fraction. Remember when we had small fractions within a big fraction? We called those complex fractions. I told you those were not just unique to limits. This, I would want to simplify this as well. So he described it as multiplying the top and the bottom by this. This is why this is okay. It's like multiplying by 1, but you just have to make sure that you distribute it, if you think of it that way. I just tell myself I'm going to multiply everything by that. Now, that's probably not the first thing that pops in your head, but notice if you consider it, do you see how the answer has this as the denominator? Or some of the choices would if it was multiple choice? Well, that's going to make you feel better. You must be on the right track, and that's where they're coming up with that. Okay, right here, multiplying this stuff times this stuff is kind of messy. We've got a negative 3 times 2. We've got a square root of x times the square root of x, which would be an x, times an x squared, which would be x cubed. And then finally, you could combine those x cubes. 1x cubed minus 6x cubes would be negative 5x cubes. So once again, I'm not saying you have to simplify complex fractions all the time, but occasionally that's the only way to simplify it. It's not going to look like this as a correct answer on the test. It's going to look something like that. So if you're not sure how to simplify it, at least consider getting it out of complex fraction form. Okay, if you got a question about this number 9, go ahead and let me know. Otherwise, keep going forward, please. Okay, I think 11 is a little bit easier, so I'm not spending as much time waiting for you. Okay, so the process to question 11 needs to be quotient rule. Start off with the derivative of the numerator times the denominator left alone minus the derivative of the denominator with the numerator left alone all over the denominator squared, and you already have the derivative. The only thing they did to simplify in this question was they realized both terms in the numerator have an e to the x, so they factored out a GCF, and then they reduced their fraction. E to the x can cancel out one of these e to the x's, and that's why their answer looks like this. You guys okay with that? Okay. Okay. Question 13 wanted you to do two things. Find the derivative and find the derivative at 0. So, even if you got this question right, follow along with me here for just a second, because there's something I want you to pick up out of this question. So, here I've got my work for question 13. I did the product rule. You see I did the derivative of this one time, left it alone one time, did the derivative of this over here, left it alone one time. So all of this is the derivative, and when you checked in the back page, that was one of the options they gave you. And then the derivative at 0, I just plugged 0 into all these x's, and that came out to be -20. So there's your two answers. And that's fine. That's technically the derivative, and that is the derivative at 0. What I want you to understand as you move forward throughout the year, there's another way to do this question. Instead of doing the product rule, if you wanted to do some algebra first, I distributed all this stuff together. It's not quite FOIL, but people last period call it FOIL. I distributed all of this. I combined like terms, and I haven't done any calculus yet. But why do you think some people might prefer to do all this algebra before the calculus? Okay, well, I still don't know the derivative, though. Right. Most people are going to think it's easier to take the power rule a bunch of times than it is to do the product rule. You got to be able to do both, but in a question like this, you really have options. If you want to multiply it all together and then do the derivative, go for it. If you'd rather do the product rule, you can, but then plugging in 0, oh, I did do the derivative, didn't I? Wait, what in the world did I do? Okay, I apologize. My math is way off here. I started combining like terms, and then I started doing derivative. Okay, combined like terms, now do the derivative. Now if you plug in 0, all this goes to 0, minus 20 is negative 20. So, I don't care which way you do it. I just want you to know that you have options. Typically, from my experience, if there's algebra you can do, like distributing before calculus, typically students think that's easier. But I just wanted you to see that you got the same answer, and even in the back, they listed the answer like this also. They listed it both ways. So whether you distributed and did the power rule 5 times, or you just did product rule from the beginning, that's fine. Okay, is there anything about 13 you would like to ask? Okay, let's try to get at least a couple more in while we're still here. So if you have not done 15 yet, please start there. put my work up for question 15. So I did the quotient rule. Derivative of the top, bottom left alone, minus derivative of the bottom, top left alone, over the denominator squared. If you distribute here, you could at least combine some like terms. 2x squared minus 1x squared gives you 1x squared, and then that's how they came up with this as the derivative answer. And then the derivative at 1 for the second part of the answer, you just plug in a 1. So all that, when x is 1, got negative 1/4. All right, we've got about 12 minutes here, so you're welcome to keep going. But where I need you to be for class on Tuesday, as I said, I want to give you a couple of these for homework, just so you have to think about them again. The more times you think about this, the sooner you catch on. So if you at least stayed at my pace here, and I was trying to give you plenty of time in between, that was question 15. So I'd like you to do at least 5 more. So that would be 17, 19, 21, 23, and 25. At least get to question 25 by Tuesday, please. And then I will give you more time to work on this before I ask you to turn it in. As always, though, if you feel like this is harder to you than it is to the people around you, do more than that. It's not extra work, you're just doing it ahead of time to help prepare yourself and catch up to everybody else. So, everybody okay with that? You do not have to do the entire thing. At least not yet. So five more past question 15. So at least do up to question 25. Okay, so you should have a couple questions for homework. Again, I really would prefer you to leave a few of those for homework, just to make your brain think about them again. The more times you think about it, the faster you're going to learn it. So feel free to keep going in class if you'd like to, but if you'd rather do the puzzle and then do the rest for homework, you can. This is the one I showed you yesterday, I think. Okay. So if you're interested in today's puzzle, it's up on the board. Once you find a good stopping place, and or at the very end of class, remember I need these book printouts back. These are not yours to keep. So just put them back on that stack, please. And of course, if you need any help with those 5, all of the questions are already worked out on the class website. So if you need help with the next 5, please use that to help you get unstuck. I don't save class time to go over questions like that when I already have them worked out for you on the website. Posted a video to our Google Classroom for the answer and explanation to the puzzle. It is a short video too. I think it's only like 4 minutes or 3 minutes or something. So.
He didn't know that. He yelled out and was like, wait, did they call the dog Buckley because of this? And the question was, what was the name of the dog? Wait, what? But Loki, I think it's existing. I was not gonna get that right.
What I'm hearing is Marshall smart video.
No. That's good.
I know, right?
Anybody figure out the combination?